Have you seen how tools like ChatGPT with vision can look at an image you upload and describe it? Or how DALL-E and Midjourney can generate stunning images from just a text prompt? And now, some AI models can even do both at the same time. They can see, read, listen, and even create all in one go. So how is that possible? Well, that's because of something called multimodal AI. AI that doesn't just work with one type of data like only text or only images, but can understand and combine multiple types of information together, just like we humans do. So in this video, we are going to break down what multimodal AI really means and how multimodal AI works, and explore some amazing real-world examples that you are probably already using without even realizing it. So first, let's break down the word multimodal. So multi means many and modal refers to the modes of information like text, images, sound or video. So multimodal AI is an AI that can understand and work with multiple types of data at the same time. For example, a single AI model that can read text, look at images, listen to audio, watch videos and combine all of this to give a better answer. It sounds a bit like how humans process information, right? So why do we need multimodal AI? So think about how we interact with the world. If you're watching a movie, you're seeing visuals, listening to dialogue, and understanding the story together. Or when you're explaining a recipe to someone, you might show pictures, describe steps, and maybe even play a video. So humans naturally combine different scenes to understand things. So old AI models were single model. They could only process one type of data. Like a text model could only read and write, and a vision model could only look at images. But real-world problems are not just text or just images, they are mixed. So multimodal AI bridges this gap, and it lets AI connect the dots between text, visuals, audio, and more. So how does multimodal AI work? In simple terms, it works like this. It takes different types of input. For example, it could take a photo and a text question about that photo. Then, it converts them into a common language inside the AI model. So think of it like translating text, images, and audio into one shared understanding. Next, it reasons over all the data together. Then it gives you a smart answer that considers all the inputs. So for example, you show AI a picture of a dog and ask, what breed is this? So it looks at the image, understands the features and responds, that looks like a golden retriever. So it's combining vision plus language to answer. Now let us go through a working diagram of a full multimodal pipeline. So as you can see the screen, first it takes different inputs. It could be a text, image or even a video. Then it encoders for each modality. Later, these inputs will be translated into common AI language. Then, a multimodal transformer uses cross-attention to connect relationship across text, images, and audio. And finally, the model generates a response. So let me take another example to explain this diagram. So as you can see, we have different inputs. So the model can take text, images, audio, or even video as input. Next is the encoders for each modality. That means a text encoder converts words into vectors and an image encoder converts pixels into vectors, and then an audio encoder converts sound waves into vectors. Next is the shared embedding space, where all these different inputs are translated into a common AI language, which is a vector space where similar meanings are close together. For example, the word car and the picture of a car are mapped close together. Next is the fusion plus reasoning layer, where a multimodal transformer uses cross-attention to connect relationship across text, images, and audio. For example, it links the word red to the red region of the car image. Next is the output generation. So finally, the model generates a response, which could be text, a caption, an image like DALL-E, or even sound. Alright, I hope this is clear now. So now let's look at some real-world examples that make it easier to understand. So first we have ChatGPT with vision. So if you upload an image to ChatGPT and ask what's in this picture, then it can describe the objects, text, or even analyze data like a chart. So that's multimodal AI. It's using both image understanding and text generation together. The next example is Google Lens. So when you point your camera at something, Google Lens can recognize the object, read the text in the image, and translate into another language. Again, it's a vision plus language plus translation all in one model. The next example could be a self-driving cars. So autonomous cars like Tesla's uses multimodal AI because they have to see the road through cameras, read traffic signals, hear alerts, and also process maps and text instructions. So they combine all these modes to make driving decisions. Next is the healthcare AI. So doctors now use AI that can look at medical images like X-rays and also read patient reports, combining the information to help diagnose diseases more accurately. But why is multimodal AI a game changer? Multimodal AI is powerful because it's closer to human intelligence. We don't rely on one sense, we combine many. And it makes AI more flexible because one model can handle text, images, audio, and more. It can solve more complex problems like explaining what's happening in a video or understanding a full conversation with context. Alright, now for those of you who want a bit more technical depth, here's a quick peek behind the scene. So as I discussed earlier, a multimodal AI uses transformer-based models, the same type of models behind GPT. So the text, images, and audio are all converted into a common representations, like a shared language of numbers called embeddings. For example, a picture of a dog and the word dog are both mapped into a similar space, so the AI knows they mean the same thing. Then, the model can reason across all modalities together and generate an output. A great example is Clip from OpenAI, which connects images and text. Another is Google Gemini, designed from the ground up as a truly multimodal model. So what is the biggest challenge? So, the different types of data have different formats and complexity. Combining them efficiently without losing meaning is still an ongoing research area. So it's not just a magic, so it's smart design that lets the AI translate everything into one common understanding. Let's now look at some of the most important multimodal models, how they work and where they are used. So here are the key multimodal models. So first on the list we have CLIP, which is CLIP, which stands for Contrastive Language Image Pre-Training from OpenAI. So let's see how it works. So it has two encoders, a text encoder and an image encoder. So both encoders map inputs into the same embedding space. So during training, it learns this caption matches this image and this caption does not match that image. So it uses contrastive learning. It pushes correct pairs closer and incorrect pairs further apart. So here is the working diagram. So it takes the input, be it image or text, and then it encodes. So an image is a vision encoder and for text is a text encoder. Then it is shared to an embedding space. And finally, it generates the output. So let's have a look at the use cases. So it is used in DALL-E and Stable Diffusion to align text prompts with images. Next, it is used in zero-shot classification, where you give it a photo of a dog versus a photo of a cat, and it recognizes which one matches the image without retraining. And then it is used in search, where it finds images similar to this caption. Next, moving on to second model, which is BLIP2. It stands for Bootstrapping Language Image Pre-Training. So let us see how it works. So first, it connects a frozen vision encoder, for example, a CLIP or VIT, with a frozen large language model, which is LLM. A query transformer acts as a bridge, where it converts visual features into a language-friendly representation. So here is the working diagram. The AI first looks at the image and turns it into features, like objects, color, and shapes. Then, a small bridge model called QFormer takes those visual features and converts them into a format the language model can understand. Next, the large language model then reasons about the image features just like it reasons about text. And finally, it generates a text answer or a caption describing the image. So, vision encoder sees and QFormer translates and the LLM explains. So let's have a look at the use cases. So first, it is used in visual question answering. For example, what's in this picture? Next, in the image captioning, where it can give it like a man riding a horse on a beach. Next, in a chatbots with vision, for example, where you upload an image and ask questions. Okay, the next model on our list is Flamingo from DeepMind. So let's have a look at its working. So here's how it works. So first, it's a few shot multimodal model. It doesn't need huge fine-tuning for a new task. And then it uses gated cross-attention layers to integrate image plus text inside a frozen LLM. And it can reason across multiple images and a long text sequence. So it looks at the image, reads your question, connects both through cross-attention and then explains it. So let's have a look at the use cases. So it is used in multimodal chatbots like look at these 5 images and now answer this question. Next, it is used in educational AI where it reads diagrams plus answer questions. Next, in document understanding where it reads text plus images in a PDF. And the next multimodal on our list is PalmE from Google. So here's how it works. So as you can see, this is the working diagram. So first, the AI gets both visual input like a photo or a live camera feed and the text instructions like pick up the red apple on the table. Next, the vision transformer understands what's in the image like objects, colors and position, and the Palm language model understands the instruction and reasons about what needs to be done. So it's combining both. The AI creates a step-by-step action plan for the robot like move forward, grab the red apple and place it in the basket. So here are the use cases. It is used in robotics like pick up the red apple on the table. Next, it is used in real-world reasoning for embodied AI. Then, it is also used in visual navigation tasks. And the next multimodal is Google Gemini. So here's how it works. It's a natively multimodal trained from scratch on text, images, audio and video. So unlike Clip, which aligns 2 encoders, Gemini has a single model handling all modalities. And it uses joint training with cross-attention. So this is the working diagram. So let me explain this. The AI takes in all types of inputs at once, such as written text, pictures, sound, and even video. Then, instead of using separate models for each type, it uses one powerful transformer model that can understand and combine all these inputs together. And from that combined understanding, it can give any kind of output, a text answer, a generated image, or even an audio response. So basically, it understands everything together and responds in any form you need. So let us have a look at its use cases. It is used in complex queries such as summarize this video and create a chart. It is used in advanced digital assistants and also in future AR, VR multimodal applications. The next model is GPT-4o from OpenAI. It's an optimized multimodal model. It accepts text, images, audio in real time. And it uses fused embeddings and parallel processing for speed. And it works as a true interactive assistant. So here are its use cases. It is used in conversational AI with vision plus audio and in real-time assistance where you upload an image and get explanation instantly, and also in accessibility tools. For example, describe surroundings for visually impaired users. So these models represent different approaches to multimodality. Some align separate encoders like Clip, some bridge vision plus LLMs like BLIP2, and some are natively multimodal like Gemini and GPT-4o. So now let us see how are multimodal models trained. So training multimodal models is much more complex than training single model models. So first is the dataset alignment. So you need paired datasets such as images plus captions, videos plus transcripts, and audio plus text. So this challenge is the text and images don't always align perfectly. Next is the contrastive learning. So train the model to pull matching pairs closer and push non-matching pairs apart. For example, image of a cat plus caption, a cat, is a matching pair, whereas image of a cat plus caption as a dog is not a matching pair. Next is the masked modeling. Mask parts of the input such as image patches, text tokens, as model predicts missing information. Then it forces the model to reason across modalities. For example, Mask the object in a caption. A dash is sitting on the table plus providing image. Next is the fusion and cross-attention training, where models like Flamingo or Gemini train cross-attention layers to integrate modalities. It requires huge compute clusters. Next is scaling laws. Like LLMs, multimodal models get better with size and data diversity. Gemini plus GPT-4o trained on massive multimodal corpora. So here are the training requirements. You need to have high-quality paired dataset, billions of parameters, and TPUs, GPUs for weeks or months, and advanced optimizations such as mixed precision or shade training. So, why is true multimodal AI still hard? It's because of data mismatch. Text is sequential, images are spatial, and audio is temporal. So aligning them perfectly is difficult. Next is limited high-quality data. So billions of image-text pairs exist but have noises and bias. Next, bias and fairness. Models learn cultural and social biases from multimodal data. For example, stereotypes in images and captions. The next challenge is compute cost. So training needs huge GPU clusters. For example, hundreds of A100 GPUs. And fine-tuning multimodal models is even more expensive than text only. And the final challenge is the evaluation difficulty. So how do you measure reasoning across modalities? So there's no single easy benchmark. So while multimodal AI is powerful, it's also data hungry, compute heavy, and still evolving. So, in simple words, the multimodal AI can process and combine multiple types of data such as text, images, audio, and video. It's already in use such as GPT Vision, Google Lens, self-driving cars, and healthcare AI. It's a big step towards AI that can understand the world like humans do. So what do you think? Will multimodal AI make AI more human-like? So drop your thoughts in the comments.